Okay, for this right here, I'm just going to do a really quick kind of idea about how to do this, put data in a calculator and perform a one sample t-test. Let's go to second. No, forget that. Do not hit second. Hit stat, edit, and we'll put in some of these temperatures from, let's do the women. So 96.4, 4, 96.7, 96.8. I'm just taking the data off of there. This one's wrong though. So you just go right back. 96.4. Okay. And then let's just pretend like we just have 3. Really you should have more than that, but we'll just use. Well, we should do more than that. Let's just do about 5 or 6 more. Okay. So let's say there's the one with 97, and there's one 97.1. There's a 97.8. There's a 98. There's a 98.4. I gotta go back and do that one. 98.4. 98.4. 0.4. Okay. So we have 8 values in there, and they're all reasonable temperatures. Okay. Next thing we're going to do is go to stat, and then cursor to the right. We want to do test. We're going to do a t-test, just a plain old t-test. So hit enter, and we could put statistics here, but we don't have statistics. We have data, so you click on data, and then press enter, and everything changes. And cursor down here, and we'll put the temperature 98.6, and then I did put the temperatures in list 1, and if we go down here, this is where you change the left tail, right tail. We want a two-tailed test as indicated by the problem, and we could do a calculate or we could do a draw. Let's do a draw and we'll see what the distribution looks like. So here's the graph, and you see that the p-value is really, really low. The test statistic is even lower. It's not even on here. So let's do stat again. Stat, cursor to the right, test, a t-test, enter, and we'll keep everything the same. Everything's still there just like it was. The cursor down here, instead of drawing this time, we're going to do calculate, hit enter, and there it is. There's our test statistic. That's basically 5 standardized units away from the mean of 0. That's pretty far away. There's the p-value here, and it's this basically says that if I assume the model is correct, that the mean temperature is 98.6, and if I took a similar samples of size 8, I would have to collect 1,000 before I even found one that would look like that. And you see our p-value is much less than our alpha value, which was 0.01. So we're going to reject the null hypothesis, and then we're going to say that there's enough evidence to reject the claim that the temperature for women is 98.6. There's the mean right there. So it's pretty low. There's the standard deviation. And that's it.